All right, it's 2 past the hour, so we're gonna go ahead and get started. Welcome. Today we're going to be exploring forecasting and budgeting for FinOps. Just to kind of set the scene, we love audience questions, feedback, and input. So please feel free to submit your thoughts directly into the Q&A box through the Zoom interface. I'll be keeping an eye out for submissions as we talk for about the next 25 minutes, and then we'll have a dedicated Q&A period to conclude the session. Just introducing ourselves, I'm Jeff Haines. Here at Anodot, I focus on helping DevOps and FinOps practitioners like yourselves maximize the value they get out of the cloud and their investments in cloud and Kubernetes. I've been in software go-to-market for about 15 years and cloud solutions since 2013, but I'm very new to the science of forecasting, so I'll be learning a lot alongside you today. I'm very honored to be joined by a true expert in forecasting, Cohen, our co-founder and chief data scientist. I don't know if you want to say a couple words about yourself.
Yeah, hi, pleasure to see everybody. I've been doing machine learning for the past, I guess, 20 years. My PhD was in computer vision and machine learning. And basically we founded Anodot with one of its core technology is machine learning for forecasting, anomaly detection, and time series analysis in general, and of course applying it to cloud cost management.
Awesome. So we're going to keep the session informal and conversational, but we do have a little bit of an agenda. We'll do a brief introduction to FinOps forecasting. We'll give you some examples of cloud cost forecasting and budgeting within the Anodot platform. Then we'll discuss the impact of machine learning on FinOps and forecasting and budgeting. And then finally, we'll conclude with that Q&A I mentioned previously. So what is forecasting and budgeting for cloud costs all about? Forecasting and budgeting work together to help your business anticipate the impact of future cloud spending on your corporate, internal, and public goals. You want to monitor the consumption of costs and continuously align segments of your cloud spend to buckets so you can make sure spending is on track. And these become especially important and complex in the cloud because of how on-demand infrastructure has transformed a traditionally CapEx world, which was predictable, easy to track with long drawn-out processes and cycles, and slow moving with the evolution measured in quarters or years to a cloud paradigm we have now where spend is operational and can fluctuate dramatically in a matter of just hours, really, due to flexibility and elasticity and the complexity of the cloud. So now if you don't track costs in near real time and continuously optimize, overspend can be very significant. So to help control spending, businesses leverage 4 types of FinOps forecasting. I'll just build this out here. Ira, would you mind kind of going through each of these and talking about the differences and maybe defining what each one is?
Yeah, so the way I like to think about it is, either top down or bottom up. So let's start from the top down. So the first part that any organization needs to do is budget planning. This is more for the longer term, typically next year, potentially longer than that, depending on the organization. And forecasting is used for anticipating based on past usage and based on inputs about what might happen in the next year or next 2 years. You can create a forecast for how much you're going to spend in the cloud. And that's really the longer term. But and this is an exercise that was done also in the old way of in the traditional data center world. But then the CapEx was assigned, was allocated, was spent, and it really didn't fluctuate much. But now, because of, as Jeff mentioned, the elasticity of the cloud, you need to be a lot more proactive in tracking what is happening and also forecasting shorter term. So really the next phase is to look at the budgets and understanding based on the budgets that were allocated to different teams and different business units in an organization, depending on the size and how they're split, to see that it's really on track, to be proactive in seeing that you're going to stay on budget and not exceed the budget, and know it now, maybe 2 months in advance, a quarter in advance, and not wait for it to reach the budget or have the budget completed and then try to scramble to understand what to do with it then. A forecast is also used to provide insights about what can be done to optimize better. So you want to look at what's happening now and optimize your cloud spend, but you can use the forecasting to also get recommendations about what should you do now to avoid a bigger spend in a month or in a month and a half. And that's usually kind of shorter term. And then there is monitoring of a much shorter term, like the end of the month, 1 month in advance, 1 month horizon, to get a forecast of what's going to happen in the next month. And I can tell you, I mean, we have stories from customers where each one of these is an important pillar, and they can make a lot of savings by being proactive, both on the planning, on the insights, on the budgeting, making sure that each team keeps their budget, and the short-term forecast. I mean, we had a client, for example, in the short-term forecast, where in the beginning of the month, we gave them a forecast to the end of the month. It was 20% higher than the previous month and what they expected. And immediately they looked, why is the forecast, what's happening? What can explain this forecast? They found that they had some servers that were, they actually spun up too many of those compared to what they were planning. And they were able, by the end of the month, to actually not get the 20% increase that the forecast said at the beginning of the month. And there are lots of examples for each one of these forecasts of how they're useful. And the main thing is being proactive, being as proactive as possible with the cloud spend, because otherwise it can go out of control.
That's awesome. So thanks for giving that overview of the real 4 types of forecasting that we think prospects and customers will leverage for FinOps. I'm going to jump into a quick demo of how we do it today in the platform. First, I just wanted to set the stage. So Anodot's a business intelligence company. We're really focused on helping you protect revenue and reduce costs and maximize the reach of your cloud investments. With Anodot Cloud Cost Management, you gain the deepest visibility and granularity for cloud and Kubernetes and the most powerful insights. You receive personalized, easy to action cost savings recommendations from an ever-growing library of over 60 types. You get to continuously monitor and control costs through forecasting, budgeting, and anomaly detection. We're really talking about this monitor slice today, and that's really where the value of our machine learning applies today. And finally, we offer immediate value. So day 0, you'll understand what your savings are going to be with Anodot. Some examples of how customers are saving really rapidly once they adopt Anodot. One customer has already saved over $7 million since adopting Anodot earlier this year. And another customer cut over $1 million of waste in just their first month with Anodot. So the savings are really immediate. And for organizations with significant cloud spend, there's really meaningful savings to be realized, as you can see.
Yeah, the interesting thing about all this, I met one of the clients that started this journey of monitoring and actually reducing the spend. And a few months before, I guess last year, they were not really concerned about their cloud spend. I think the economy was doing really well, the company was doing really well, and kind of the cloud spend was left to the side, and there were higher items. With the economy slowing down and all of a sudden spend, you want to reach profitability or maintain your profitability. And in a soft economy, one of the ways is to reduce spend, and reducing wasted spend on cloud is the easiest form of achieving that, because you're not cutting anything from your business. Really, you're just you might have let your business kind of run wild with the cloud. Once you start doing this, the savings are enormous, and it goes directly to the bottom line of the company. So it's really amazing to see once again, every time, again and again, from clients that start looking at it a bit more carefully using tools like Anodot and realizing savings of millions of dollars.
Yeah, it's really is all upside, and I think that's what's great, and the way we help companies identify it. I think sometimes it's just hard to get in there and know what to look for, what to do, and that's really what we specialize in with the recommendations we offer. So, obviously, companies are seeing a lot of value in that, and we're, internally, we're really excited to see that this value is happening so immediately as well. So, we're seeing that the recommendations we're offering resonate with these companies, and they're things that are implementable for these companies, so they can see real value. So jumping into specifically the machine learning powered forecasting we have today. So here's an example of a short-term cloud cost forecast from an Anodot dashboard. You can see that month-to-date costs, they've had spend of about $3.25 million at the time this screenshot was taken. The machine learning is forecasting that total monthly costs will be a bit over $5 million. Moving down here to the graph, you can see this teal line here, that's representing previous month spend. And then this blue area here is tracking spend to date this month. So you can see it ends when this was taken around the 18th. The dotted orange line here is representing the forecast for the remainder of September. So this is back to that short-term forecasting we talked about previously. Is there anything else you want to say here, Ira, that might be helpful?
Yeah, and then you can see it also shows that it's 27% lower than the previous month, anticipated to be lower. And this is an example where, again, the optimization recommendations show up in the forecasts as well, and basically achieve savings that are significant, quite significant.
That's awesome. So I also just wanted to drill in quickly to our budgeting capability. So we're able to configure budgets today for business objects like linked accounts, services, teams, and projects. That's what each of these line items is, different kinds of budgets. This overview screen shows your current spend for the month versus, or the period versus what's budgeted. It also showcases what your forecasted versus budgeted spend is going to be. So in a lot of these cases, they're predicting overspend. Drilling into one of those budgets in particular, this is for all of AWS. You can see the organization configured a budget target of a little over $1 million for the month. When this was taken, they had spent just about $600,000. And then this blue area is showing the forecasted cost, which with September 21st today actually showing when they were projected to start overspending their budget. So the key thing here that we offer, aside from enabling you to visualize this and track your budgets, is to ensure that you respond quickly. There's email alerts you can configure for each budget for any percentage forecasted or realized, and you can alert any audience, right? So the right people are getting the right alerts and can respond and make changes to your infrastructure as required to prevent this case of overspend. So now Ira is going to help guide us through how our forecasts are generated. The first slide here, these are some of the requirements we set for our forecasting capabilities. But before we kind of drill into these, I wanted to ask a question that I have personally. So machine learning, just from being in this segment of the industry for a few years, machine learning and AI were real popular marketing topics a few years ago. For companies in the cloud cost management space and the cloud management space. But it turned out a lot of what they were offering was kind of smoke and mirrors. And when companies went and implemented these features, they didn't really see the results that were promised. So for me, looking at Anodot, we've got some, what seem like similar claims on the surface. Machine learning is going to enable you to achieve these results. What's different with what Anodot's offering, and what's different now from what maybe some companies were offering in the past?
Okay, so basically when we founded Anodot, the machine learning was a core tenet of the product itself. And I think that basically means that our focus, the main value that we said the product will give is based on what the machine learning will give. So if we didn't achieve it, basically we would fail. The company would fail. So that already puts a lot of pressure. I think the problem that I saw in the industry in the previous years is that there was a push from the industry and from investors to say you're doing machine learning, you're doing AI, you're doing machine learning. So every company felt compelled, even if they didn't have a data science team or machine learning experts, they felt compelled to say that they have it. And I think that resulted in poorly designed and executed features in products that were supposedly based on machine learning, but were either done with some consultant that came for a few months and built something and went away, or with open sources, thinking that they can just take an open source and it will work and everything will be fine, not realizing the complexity of designing and creating a machine learning based product. And that's something that's hard. You need the experts you need the experts, and you can never stop. I mean, it's just like any other product, any other software product. You can't just, if you build a product, you can't just get rid of your R&D and let it go. You have to keep at it. And because machine learning is something that improves over time, as you see more data, as you encountered more situations, and you let your models learn more things, just like an autonomous car. You know, it needs to see billions of miles driven before it's really, really good. Here it's the same. You have to build it. You have to start letting it consume data and constantly let it improve with more and more data that it sees, more and more situations that it sees, improve the algorithms, improves the model. And that's how you get good results. That's how they got good results. That's how the industry gets good results now with speech modeling, with natural language processing, with images, more and more data, more and more situations, teams that are dedicated to constantly improving based on that. And that's how you get good results. And that's what we did basically for the past 8 years.
Is there, I mean, that's really awesome. And I think the differentiator is that, you know, we're foundationally built as a company on that basis of applying the science to everything we do. And this cloud cost management has kind of come out of that as one of the value drivers that we can add. Is there anything else you want to talk about in terms of like the effort that goes into sort of achieving these 4 things and what we've done as a company to develop these?
Yeah, so just to mention the requirements. So there are 4 main requirements. Forecasting needs to be granular, meaning that we're not just forecasting the whole AWS account. You have to forecast to different teams and then to different types of services and different clouds for GCP and for Azure, and take into account everything that's happening. So it has to work at scale and it has to work granularly. It can't be manual. It has to be accurate, of course. We'll talk about accuracy in a second. And it has to be also flexible. So things change. You want to gain forecasts on different things. And we decided that it should not require a data scientist on the client side to actually get forecasts. And it has to be a standalone plug-and-play product that works without a need for for any configuration. So that's kind of the requirements. In terms of the effort, so actually, I'm going to talk about, if you go to the next slide, when we built our forecasting, to a lot of different things. So let's go to the next slide for the effort, actually, before we go into this. Yeah, so it's actually at the end. Therefore, more.
Sorry about that.
Yeah.
I think I'm a couple slides behind you.
Yeah. So yeah, here, the slide before. Yeah, so forecasting is a general problem. It doesn't just apply to cloud cost forecasting. And when we build the forecasting capabilities, we build it as a generic forecasting capability. And this is an example from one of the clients that we talked to, and of what they had to do to get demand forecasts for products of food manufacturing. And here, they told us, they estimated to get. This is a medium-sized food manufacturer. They spent 107 human years to build their demand forecasts. If you go to the next slide, we broke it down. What does it mean, 107 human years? It's a huge cost. So they're selling around 5,000 products. To create a forecast for each product takes about a week for a data scientist. So that's 96 human years just to create the initial demand forecast. And then, if you click, you get about 25 new products per month, about a week for each one. That's 6 human years to achieve that. And then you have to update your models. So, things change. You have to update what's happening. You can't let it go stale. What worked yesterday or what worked last month might not work in 6 months from now. So that's another 5 human years, and all of that totals to 107 human years. Now the cloud cost forecasting is not very different. 5,000 products. Think about how many services, how many types of servers you want to forecast their cost. You could reach this number easily, especially if you were a large organization working in multi-cloud. new services come out all the time. So you have to create models for them as well. And things change all the time. So you have to update things all the time. So if you had to do it with a data scientist, this would be approximately the same amount of effort.
Great. And that's, I think, also speaks to why companies wouldn't necessarily want to go and build this out on their own. It's something that's going to be not only difficult to develop, but it's going to, cause a lot of continuous costs to maintain something like this and keep abreast of changes to the infrastructure and the service offerings that the clouds are offering.
Right.
So I just I have to jump back in my slides now. Oops, sorry, I'm a little bit.
So how about you unshare and I'll share my slides.
That works perfectly. Let's do that.
Yeah, let's do that. So I think we wanted to share now kind of what are the what's the machine learning behind the scenes and what does it take to build such a system, and really, this is our blueprint for a large scale forecasting platform. Remember, we are doing the forecasting for all the clients, for all their services, and it could be, millions of things that we need to forecast. So it has to work automatically and at large scale. So basically the components are, we decide what to forecast, so there are out of the box forecasts for any account, and then any client can adjust it to forecast different things for budgeting, for short term, for longer term. Then the system goes into automatic mode. It first prepares the data, and I'll talk about some of the preparations that is required. And the type of models that we use are all time series based models, because what is the cost of a cloud? It's basically things you measure it over time. So you have to look at it over time. And the types of algorithms running there are, neural networks like LSTMs, recurrent neural networks, open source models like Prophet, linear temporal models, boosted decision trees. And what we found from all of our experience and experiments, that there isn't a single model to rule them all, a single algorithm that does the best for everything, even if it's the same cloud cost things. And you have to really train an ensemble of models in order to get to the accuracy that you need. And then in terms of our system, this whole process happens automatically, so nobody has to touch it, neither on our side or the client side, except for deciding, I want to forecast this part. And then it starts continuously forecasting. Every day it adjusts the forecast and updates and produces the results into the dashboards and potentially into alerts for budgeting purposes, for if you're going to, an alert if you're going to exceed your budget and things of that sort. So that's really the system, and this system is closed loop. It has to constantly update what the models learn, because things change all the time.
So, and obviously this is very over my head, and I get the sense of the flow, which is great. You'd mentioned accuracy, though. I know you wanted to kind of go into the types of accuracy, what accuracy can be expected from a solution like Anodot, and give a little explanation of that. Is that something you'd be comfortable sharing here?
Yeah. So first of all, how do you achieve accuracy on forecasts? And this is in general for cloud cost and for any things you are trying to forecast based on time series. You want to take into account historical trends, what's happening in the trend, and trends doesn't have to be linear. So a trend doesn't have to be a linear line. It can be all sorts of things. You'll want to be able to account for seasonal patterns. You might have, in cloud costs, we see all the time, the weekend, the costs are lower, during the weekdays, they're higher. You could have a monthly pattern, you could have a quarterly pattern, you could have an annual pattern. You have to let the algorithms figure that out in order to gain accuracy. You want the system to be able to take into account special events, obvious special events, holidays like New Year, but it could be campaigns, it could be a new product that is released to the market, it could be all sorts of things. You want the system to learn how those special events impact your cloud cost, so that you can anticipate that, because these special events are known a priori. They're not coming out of the sky. You know that you're going to release a product in 3 months. So it's not something so you can let the system anticipate based on what you already know. And these are special events. And it has to be adaptive. Adaptive meaning it has to adapt to shifts that may happen. This is an example, a real example from a real customer, where you can see how the demand changed dramatically once COVID-19 started. And you have to let the algorithms adjust to that as well. So they have to be adaptive. You can't let them go stale. And the last thing is robustness to anomalies. What does that mean? Anomalies happen. So sometimes you might have a team that spins up lots of servers by mistake and causes a spike in the cost. You can't let the algorithms learn that, because that's unexpected. They have to be robust to those kind of unexpected costs, or take them into account in a special way. So these are the main factors for achieving an accurate forecast. If we go to the next slide, I'll go to the next slide. I'll show a very, very challenging example, one of the most challenging examples we've had from a client, where the forecast, we were required to produce a 7-month forecast, and this was beginning of May, I think, 2020. So a month after all of COVID started. And the client wanted to know what will be the costs for the next 7 months until January. And then we gave them a forecast in May, and then they showed us this graph, because they compared us to other tools out there of how we did compared to other tools that they ran themselves in May. So the red line is what Anodot produced. Very, very challenging period, very different from everything. But our accuracy was 84%. They used 2 different AWS based on SageMaker, 2 different models. They got 62% accuracy, 51% accuracy. Prophet, which is an open source that is widely used for forecasting, was also much poorer. And that's not surprising, because first of all, we train ensemble models. We take into account a lot of different factors that some of these algorithms, unless you change them and modify them as we did, they don't know it. They don't know how to handle it properly. And then they don't get good accuracy. What I can say, in normal times, our average accuracy, nobody can promise an accuracy that will always be achieved. If anybody promises that, they're lying. But we see from our experience that we get from anything from 95 to 99% accuracy in our forecasts, which is very good for all the planning that is required, especially considering that you're looking for overspend of 10%, 20%, so that kind of accuracy is sufficient to take a lot of actions that are meaningful.
And that aligns well with, I think, the FinOps Foundation today promises, they say if you're a run organization, a very highly sophisticated organization, you're looking at probably high 80s accuracy. So we're even above that. So that's great to show that, how sophisticated our model is and how it's really leading. I wanted to move into Q&A here quickly, and I'll throw up a slide in a second, but we've got actually a number of great questions, and I hope we can get through all of them. So the first one is, regarding forecasting, does the solution do calculations based on past behavior only, or is it using ML or AI to consider something that's scheduled to be up running in the future? So I think this is, maybe we're adding infrastructure down the road. Is the model going to be able to consider that? Maybe talk about the problem and then what the solution is.
Yeah, so first of all, the main inputs to the machine learning models are the history of what happened, but there are also inputs of what can happen. And I mentioned, that there is going to be a product release 3 months from now. That you're going to sign a big customer of a certain type in 6 months, and they're going to onboard in 6 months. So the models also take those into account in the forecasting. Of course, the numbers they give it are based on similar things that happened in the past. Otherwise, they can't know what's the impact of those events unless you can specify, this event will cause $2,000 of spend. But usually nobody knows that. So basically, it leverages similar events that happened in the past to predict what will happen in that particular event. So that's the answer to that question.
Great. This one's similar. I don't know if you can give any different answer to it, but it's saying, how does Anodot facilitate incorporating new data elements or features on a continuous basis? So I assume this is like it may be more around like methodology of including more things. Actually, there's another question here that just popped up that's good too. So I don't know if is that sufficiently different from the previous question or?
Yeah. So basically, new data elements. So the way we handle it is we retrain the models on something like a weekly to monthly basis. So we don't let them go stale, and we take all the inputs. So part of the way the system works is it takes all of the inputs and learns a multivariate model. So if there are new inputs, new features that start coming in, they will be taken into account to try to incorporate them into the forecast. Of course, when they just start, there's no history to them. They don't help. They don't help much. But once they have a little bit of history, they actually start impacting the forecast significantly. And that's really the way, one of the ways we achieve adaptivity to new features, new things that come along, and it happens automatically within the system.
That's great. And there's a final question here. So this is, I think more about like adjusting to the pricing, and I'd say that it says over a period of time, cloud service providers reduce their pricing, which I'll say is not always true. And we have seen cases where it goes up. But how do you handle such situations and how it affects the model? So changes into the actual pricing of the instances or other service costs.
Right. So the good thing is that we have those within the product, the lists of prices. Of course, we don't know when they will do any discounts or increase prices. So that's something that that is not known. But once it does happen, it does adjust the forecasts. And it is a bit complicated because sometimes these new prices are not that easy to track. It's one of the harder problems to solve just because of it's not hard from the machine learning point of view. It's hard from the data collection point of view and incorporation integration. But that's because that's what we do as a product. We always try to keep on it and make sure that we don't miss some of those things within the product.
Absolutely. And I think one of my takeaways is that this is definitely not easy. It's very complex and a lot of ongoing work. It's not just a one and done, we release a feature and it's there. It's a continuous battle uphill to be increasingly accurate and deliver more value. So that's great. So unfortunately, we're at time. We're a little bit over time. So we are going to conclude. I just want to thank everyone for these excellent questions. If we didn't get to your question, we'll follow up with you via email. Also, feel free to follow up with us directly if there's something we didn't answer or you have an additional question. Just want to thank everybody for attending. Thank Ira so much. Thank you for your time and your valuable insight. And we'll be sending out the recording to everyone as well. And you'll get an invite to our next webinar as well. We'll hope you'll attend. So thank you, everybody. Have a great remainder of your day. Take care.
Thank you. Bye-bye.
Bye-bye.